Thanks, Cameron. Hi, everyone. Today I'm here to talk about one miner's need to future-proof their operations by cutting OPEX and developing a more sustainable method of mining. This endeavour ultimately took them on a journey that resulted in the development of an alternative truckless or acquisition technology. But more importantly, it demonstrated that with the right level of discomfort and appetite for innovation and an emphasis on developing trusted relationships underpinned by science, they were able to develop results that went far beyond their immediate needs. This story is relevant to us today because we find ourselves at a point in time where our industry as a whole is playing R&D and technology catch-up compared to others. And much like the rest of society, we've developed an insatiable need for innovation and rapid product development. It's difficult to think of too many other times in our history. Sorry, my clicker's playing up here? Oh, sorted. It's difficult to think of too many other times in our history where it's been more difficult or onerous to be in the mining game. So the important question to be asking ourselves is, what do we need to do to future-proof our industry? The challenges facing the industry are many, and they've been there for a long time, so we know there's no silver bullet. But at NT, we've seen a distinct trend in the markets we're involved with. There's increased scrutiny across the board, whether it be in the public's opinion sector or internally within organisations. Controlling operational costs have become more difficult. Opportunities to extract value from lower grade deposits are harder to justify, and new mine and mine expansions are becoming more and more difficult to get approved. So even considering a short list such as this, how do you make sure you have the best project on the block that attracts investors? The goal of today's discussion is to try and shed some light on a possible alternative and talk about how one organisation accepted this challenge to unlocking the potential of their deposits. Our belief is that these problems can't be solved by simply adjusting the status quo to meet our current needs. If we want to make serious inroads into future-proofing our industry, we have to reimagine how we mine and process minerals. We need to shift our thinking. Today, we're going to discuss how Chemours and Southern Onyx Minerals invested the time and effort to embrace innovation, to embrace innovation, to develop a new technology, and how they took that initial leap of faith. We know that progress isn't always linear. Troubleshooting, refinement, and optimization are inevitable. We'll talk about how collaboration was key in resolving these issues, and we'll talk about how the use of strategic alliances were fundamental to developing new technologies for a sustainable future. The focus of this discussion will be centred around how they transitioned from a traditional truck and shovel operation to a truckless and dredgeless operation. So why take the leap in the first place? For Chemours, future expansion plans meant existing technology was no longer viable. They no longer had large, continuous ore bodies. The deposits were small, shallow, and discontinuous, located close to the local community, residents, and homes, schools. They had a high level of discomfort. They were running out of ore. That was not only affecting their ability to operate today, but also in the future, and they needed to do something about it. MT was fortunate to be engaged early in this initiative by Chemours at the concept phase. The target Chemours set was clear: reduce ore acquisition costs by 30%. But this wasn't the only criteria. Safety, mobility, oversized handling, and minimising the broader impact of mining were all critical. They wanted to get human beings and rolling stock interactions down to a bare minimum. They wanted to make sure that the new technology was highly mobile, that it could move around from these small patchy deposits, and they wanted to be able to spread the asset cost and the recovery of that across several lifetimes. And then the oversized handling was a critical piece for them. This area in the US has high volumes of organics that, after more than a century of foresting, makes that first initial cut very difficult to handle without getting inundated with trees and roots and stumps. And they have a hard pan, which is basically conglomerated sand. It's quite friable, but it's got heavy mineral in it. So how do you extract the value in hard to get places? And then finally, obviously, minimising the broader impact with the local communities. So for the mineral sand miners in the room, I guess the obvious question for us is, well, why not dredge? There's a few reasons for that. Ore body makeup was one. These were smaller, discontinuous cells, and relocation costs, moving from cell to cell, would have been expensive. The community impact was real. These guys were going to come right up to the back fence of their neighbours. They were near schools. So there was a visual impact, dust, reversing alarms, noise, all those kinds of things. And then there was also the environmental license to operate constraints that they were faced with. They were close to wetlands, sensitive areas, and dredging was frankly frowned upon. So traditional dredging is out, and after assessing a variety of different technologies against an agreed success criteria, the team came up with the mobile mining unit. The MMU is a highly mobile feed delivery system capable of processing between 500 and 1,000 tonnes per hour of ROM. From a functional process standpoint, it's very simple. Feed it, wet it, shred it, pump it, and roll on. One of the key drivers behind the development of the MMU was trying to imagine how we can bring the mineral separation process closer to the pit. But if I can steal from Jim Jarmusch, nothing is original. In developing the Chemours MMU, we springboarded off a small scale and respectfully somewhat agricultural concept previously developed by others. We reconfigured it, we re-engineered it, we beefed it up, we increased throughput, and we worked out a way to apply it to a new problem. But it wasn't without its issues. Like most new endeavours or trying something new, there were challenges. No one had ever done this before. There was a whole bunch of new stuff that we just didn't fully understand yet. Many of these were small, typical prototype issues that resolved themselves in commissioning. However, there were some major issues that threatened the overall success of the project and ultimately Chemours' ability to expand their Florida and Georgia regions. In short, the MMU wasn't pumping oversized organics. In theory, we had a solution that we thought we had a solution that was able to size material to an appropriate pumping size. But the reality of that wasn't quite the case. The pump would consistently block whenever it was inundated with organics, which was very common occurrences when operating in the first cut. We dragged subject matter experts in from all over the world, pumping experts. We tried all different types of pumps, traditional centrifugal pumps with different impellers, root choppers, screw pumps, even fish pumps and fit-for-purpose dredge pumps, all with very limited success and significant shortcomings. We were under pressure to perform. But it was during this time that Chemours and MT started working together closer than ever before, both instinctively knowing that the solution to this problem would have to come from transparency, collaboration, and trust. We could have easily been upside down on a commercial bind with the customer, but both project teams were given enough space to do great work and to get solving on the problems at hand. Up until this point, we've been failing because we were ignorant. We were ignorant to how the shredder was actually really designed to work. So we studied it. We persevered, we tested the OEM, we asked a bunch of questions, and finally the aha moment came. The performance of the shredder was governed by the number of hooks per knife. Realizing this, we collaborated with the OEM to develop a new shredder knife design, and the success that came from this, from Chemours and MT's unwavering pursuit to solve the problem, embracing the balance of input between technical subject matter experts and lived experience with the operations team out in the field. So resolving these issues triggered the performance acceptance test and handover of the unit to Chemours. This was one of the clutch moments in ensuring the Jessup mine development was given the green light. The Maxville unit proved it could handle hardpan. It could handle the distinctive heavy organic laden material that was typical of the Florida-Georgia region. The Maxwell operation further demonstrated it could operate at full production capacity and not depend on haul trucks to tram material from the pit to the process. Good news for their neighbours at Jessup. So with the wind in our sails off the back of Maxville expectations for a bigger and better Mark II unit were high. The customer expected us to knock it out of the park, and our business, MT, expected us to be able to deliver exactly what we said we could do. So it's fair to say that there was a healthy tension at a B2B level between MT and Chemours, but also internally within the respective project teams at MT and Chemours to drive the need for success. So what better way to improve prior learnings than to open the doors and invite the client and specialist OEMs in to collaborate with us and to get into the thick of the Mark II design process. And it ended up being a great result, with huge operational, maintenance, and reliability gains made on the Mark II model. Major changes in the design, such as dual side feed, meant that they didn't have to continuously tram back across the cut, so they had improved uptime and throughput. Lower overall height improved the cycle time of the excavator, and the need for temporary benches to sit the excavator on were eliminated. Ultimately, the unit delivered well ahead of the client's expectations and schedule and progressed smoothly through commissioning. But the Jessup project was about more than just truckless mining for Chemours. While the MMU allowed Chemours to fulfill their commitment to stakeholders, in some respects, Jessup was about changing the public perception of mining that had developed over the many years of mining in that region. So the sole focus for the endeavour couldn't just be on throughput, recovery, return on investment. While those metrics are essential, they do limit the longer-term value proposition and generally have a very short-term focus. The Jessup operation needed to be a step change for Chemours. But how do you manage or create a step change of this magnitude within your team or organisation? The truth is that there's probably many ways, and lots of incredibly intelligent people have written books, papers, and made careers from explaining those methods. I can't teach that, I can barely speak to it. But what I can share is what I observed between Chemours and Southern Iron Minerals. Two organisations facing different challenges, but ultimately the same problem. Their future, the growth of their respective businesses, was under pressure. They had access to different resources and brought different strengths to the table, such as financing, funding, people, mine leases. But the challenges and the risks of going it alone, were great. Out of this struggle grew a strategic alliance and a new level of collaboration that became key to their success. To speak to this, I wanted to introduce Stuart Forrester, Minerals Operations Director at Chemours and Southern Inex.
Hi, Stuart Forrester here from Chemours. The mineral sands industry is relatively small, with many of us knowing each other. Despite this, we typically operate in silos, with the likes of MT attempting to connect the dots between good and better to drive us towards innovative and sustainable solutions. Through the building of trust, Chemours, Southern Inex Minerals and MT were able to create a win-win-win outcome in the development of new sustainable technology, the mobile mining unit. The trusting and collaborative approach resulted in many wins, including shared design, improved safety, lower environmental impact, and lower operating costs. A resultant outcome was the extension of mission mine life by a massive 9 years, a shared positive with our local community and our customers. The essence of how we achieved this was transparency. Transparency that facilitated a trusting partnership and later an acquisition of SIM by Chemours. Milton Sunback, the former private owner of SIM, was an inspiration in forging that path, constantly reminding us of the importance of trusting relationships. My thanks to Matt and MT for supporting this new approach, engineering excellence, and for executing on our three-way vision.
So apologies everyone, unfortunately we couldn't see the video live there. I promised we didn't do a voiceover for Stuart, that was his actual voice, but the video was actually just him talking in front of that image there, so we didn't miss out on any content. I do apologise for the technology issue that we had there, but it was great to hear from Stuart, and as he shared, transparency was at the heart. Oh, I've got another glitch. There we go. As Stuart shared, transparency was at the heart of our joint success. And these relationships that were built on trust is what enabled Chemours, CIM and MT to take the MMU from a concept, an idea in people's heads, to a fully functional unit. The MMU project played a modest part in helping foster a strategic alliance between two long-term competitors, shifting headspaces from competitor, where the focus is really on win and lose and have not, to one of rival, which is far more complementary to creating a culture focused on performance excellence and continuous improvement. And although the MMU wasn't a silver bullet, or it wasn't a Hail Mary pass that allowed CIM to extend their mine life by 9 years, it became a catalyst for broader change, a launching pad to think differently and being ambitious with our problem solving, which ultimately brought about a great result. 9 years of increased production at a higher recovery, 9 years of more jobs, a reduced environmental impact, improved safety, and a positive contribution to the community. So how do we achieve project greatness? For us at MT, it comes down to 4 things. Be ambitious when setting the value proposition and set it early. This sets the trajectory for the project. Do quality testing. Know the material well and adapt and develop equipment to deliver the process. Functional plant design, everything you need and nothing that you don't. And finally, a delivery strategy that leverages opportunities and networks. All this leads to a project that is valuable, gets funds, and delivers value to stakeholders. So in closing, I'd like to leave you all with one last thought. Next time you're assessing a new venture, project, or upgrade, pause for a moment. Avoid simply adjusting to the status quo to meet your current needs and take a moment to reimagine what perfection could look like. We need to stop and ask ourselves simple but often challenging questions like, if this were easy, what would it look like? It's important to do the reimagining as early as possible in the project lifecycle, so the solution is ready when you need it. If we can create a clear picture in our minds for what success looks like, bring the right people to the table at the right time, and use a science-based approach to work our way back to what is realistic and sustainable within the constraints of what we have, we will immediately be better off than just taking what's been done before and trying to solve and trying to be satisfied with the outcome that renders. Find the right team of people with the right skills who you can collaborate with, who you trust, and who will work with you to solve these complex problems together. There are plenty of them in and around our industry. MT considers itself to be one and has a strong network for achieving project success through effective collaboration. Thank you.
Awesome, thank you. More a comment than a question just from me, but I can really see minimally invasive mining being a key theme for mineral sands and probably other commodities as well, going forward for a long time. Couple of questions from the audience. Why did Chemours engage MT directly, they assume, as a paid study instead of approaching the market through a competitive tendering process?
That's a good question. To be honest, the beginning of this was about them realizing that where they were operating, they were out of ore and they needed ideas, they needed concepts. So they didn't actually go down the path of a traditional PFS or sort of concept study. They were actually really looking for an innovation partner. And I think back in 2014, perhaps, there was maybe one other engineering group that they were talking to at the time. But really, it was the relationships that existed between different levels of the Chemours team and within the MT group, and the on the ground presence of the team there in the US that made them feel comfortable that we were going to be able to help them think differently, to be more of an innovation solutions focused engineering house, rather than trying to produce an effective study to engage broadly with the market. They were privileged in that they could bankroll and fund a lot of the project themselves. So it was really about what's the technology solution that we need to solve this problem.
Beautiful. And the other question we had was, where do you see this MMU technology, minimal invasive mining, I'm assuming that heading in the future, is this a universal solution for most ore types or just bespoke to this project? And I presume they mean across mineral sands, but also other commodities. And I'm personally curious to know if you've looked at other projects and perhaps Australia.
For sure. Yeah. No, we've spoken with a lot of the majors around this. The elements I think within the current MMU that are probably bespoke to this particular project was the shredder that really had to deal with the high loading of organics in old forestry, tree stumps, and all that kind of stuff. But at its core, it's a track-mounted sump and pump arrangement. And we've played with different concepts for different pre-screening, comminution, crushing, braking arrangements. So there's a high level of flexibility for it to be applied to a number of different ore bodies or minerals. In terms of the future, I see a good future for the MMU in tailings recovery. So going out and doing sort of spot collections around a previous tailings deposit or something like that. In terms of the iron ore game, it's probably not going to get the tonnages that iron ore would typically require, but very capable of 1,000 tonne an hour kind of capacity. So anywhere for tailings recovery, beneficiation, those kinds of things, or tricky deposits.
Great. I gotta remember to unmute myself, but I think, as we know, tailings recovery becoming another key thing. Lots of companies looking to develop some technology to recover tailings, and so awesome, very relevant.
I appreciate your time. Thanks very much for having us.